The auto switch, an idea that was brought to life by group members Amine Miadi, Asmae Miloudi, Hiba Lehjef, Laabid, Imane Fath and Ayoub Mabkhout. A device that can turn the light off at a time when it's no longer needed. This idea came in light of one of the 21st century challenges, energy conservation. Around the world, scientists are doing research to find novel methods for generating energy and conserving it. But the simple act of turning the light off can make a huge difference. And so we thought if people don't always do it, then why not automate it? As a team, we went through different phases of work effectiveness. We were already acquainted through different classes, but we have never worked together. At first, we had several disagreements and issues to be solved, and we didn't know each other's dynamics and way of thinking. But as the time passed, we moved from a pseudo team to a potential team to a real team, and finally achieved the level of high performance not as individuals, but as a group.
Before we get to the phase where we actually build our product, we've had to set up a number of requirements so that we do not fall into miscommunication issues during project development. So we've made a prioritized table in one of the previous phases where we split the requirements into two categories. Demands here marked in D and wishes here marked in W. You can notice that the wishes here are ranked depending on importance value. I am glad to be able to say that we've managed to meet pretty much all of the demands that we've set, or at least most of them, during the requirements phase. When it comes to the wishes, we've had to omit some of them, like the last one, because of a lack of time.
After going through the requirements, we were able to move on to the functional analysis. We used the black box to determine the main function, which is to switch the lights off automatically, as well as the inputs and outputs. Then, by decomposing the main function, we got the following function tree composed of the main function and its subfunctions, which are to allow the user to configure the time, as well as to first determine the state of the lights, then send an electric signal, then activate the relay, and finally open the circuit, therefore turning off the lights. And by combining everything that I have mentioned so far, we get the function structure, which contains the inputs and outputs, as well as the function and its subfunctions.
So after the functional analysis of our product, we define the specifications. As we can see from the table, a specification consists of a metric, dimensions, weight, selling price, etc., and their value. The common method to establish the specifications is the performance specification method, which is the one that we used for our project, the auto switch. And the metric we chose are derived from the functions of our product that we established before. We then have the house of quality, which aims to compare how much the specifications that we came up with match the consumer's requirements. It also helps us calculate the absolute importance and the relative importance for each one of the specifications and their requirements in order for us to achieve the satisfaction of our customers.
Then we passed to the concept development phase, where we established our morphological chart that enabled us to choose the optimal solution from the set of options that we have for each parameter. Of course, with the use of the solution space tree diagram and the decision matrix. At the end, we settled on using a set of definite solutions to meet the customer requirements mentioned earlier. For example, we use the Arduino board rather than an integrated circuit, a battery rather than power plug, and an RTC model to configure the time, without forgetting the use of a combination of both the screen and push buttons in order to interact with the user.
Our product will be dedicated into mass production. We divided our costs into fixed and variable one. The fixed costs include the investment expenses and the overhead costs. They include the technical and non-technical services, the general supplies, and the equipment rental. We have also the management expenses that include the share of the corporate executive staff, the legal staff, and the corporate research and development department. In addition to that, we have the selling expenses. The variable costs include the material, the maintenance, the packaging, and the scrap expenses per product. Our total fixed cost is $20,330. Our variable cost is $40 per unit. We set our selling price to $50, and to make this activity lucrative, we need to manufacture and sell 2,033 units, and if we make less, we will make losses.
Here is the final prototype. Let's hop in the back to take a look at the parts. We can see here the Arduino board, which is powered by a 9-volt battery. The board will be sending a signal to the relay to open and close the circuit, and therefore turning the light on and off. Here you can see a real-time clock module. We used this module for maximum time accuracy. And in the front you can see the interactive panel. We have our breadboard inside, which we connected all our parts to. We have 4 buttons and an LCD screen. For this demonstration, we will be using a 220-volt light bulb. This here is the main menu. In the main menu, you can see the date and the time. We use these 2 buttons to move back and forth in the parameters menu, and when we're in the main menu, we can use this far left button to turn the light on and off, just like a regular light switch. So let's hop in the menu. We can here configure the current hour. We'll set it to 11 p.m. 11:59, here are the minutes, and 50 seconds. Here the current date of the 31st of December 2020, and the off hour to 12 sharp. So here we're back in the main menu. We can still use this button to turn the light on and off regularly, but when the light is on and the timer hits the configured time, as we see, the light turns off. So this concludes our project demonstration and I guess the introduction to engineering class. It has been an eventful year, but the making of this project has been really fun. Thank you for following up. Thank you for the effort, and stay safe.